Okay, finishing up making my 5th online lesson in one conference period. Not bad. It's actually a lot more work than that. I had to pre-make all these on another day and pre-record answers on another day. It's actually like a 3-day process to make 5, but either way, things are going pretty good from the technical aspect today, so I'm in a good mood. All right, so we're going to start talking about repeating decimals today. Now, some might call these non-terminating decimals. Non-terminating, terminating meaning stop, so non-terminating mean never stopping. But these are a certain kind of non-terminating decimal. They never stop, but they do repeat. And repeating decimals are rational numbers. Let me repeat that. Repeating decimals are rational numbers because they can be written as fractions. All repeating decimals can be written as fractions. So let's write each fraction as a decimal number. Okay, well, if you've got a calculator, you should be able to do this. Okay, 3 divided by 11, when you see it on the calculator, you'll see 0.272727. You might see it end with a 3 depending on how far your calculator goes out. But the only reason that 3 is there is because it's rounded, and we'll get to that on the next slide. But if we're going to write this as a decimal number, that pattern continues forever, so the easier way to write it is just to write 0.27 with a bar over top the 2 and the 7, which indicates that both the 2 and the 7 are going to repeat forever. It's a lot cleaner to look at. And let me give you a little vocab word here that not very many people know. I bet you even if you ask some other math teachers, they might not know what this bar right here is called. And I want you to remember it. Don't write it down. Don't write it down, because if somebody asks to copy your note sheet, you'll know this word, and they won't. This bar right here is called a vinculum. Vinculum. So tomorrow's password to get into class is going to be vinculum. If I forget, you tell me, okay? Vinculum, V-I-N-C-U-L-U-M. Don't write it down. All right, let's do this again. 2 divided by 9 is 0.222. ... means that continues forever. So the best way to write this is 0.2 and put that vinculum over the 2. Vinculum. You're only going to know that word if you actually listen to the audio of this video. 2 2/3. Okay, well, first of all, the whole number is 2. We do not need to turn this into an improper fraction. It's a complete waste of your time. Just write the 2 down, and then 2 divided by 3 on your calculator is 0.6 repeating. Okay, so you'd see 2.666666, which is the same as 8 over 3. If you type 8 divided by 3 into your calculator, you get 2.666666. All right, and then last one, 1 divided by 30. That looks like this. 0.03 repeating. So the 0 actually appears in there, then the 3 starts repeating. Okay, 1/3 is 0.3 repeating. 1/30th is 0.03 repeating. So you could imagine, what do you think 1/300th is? Is it 0.003 repeating? Type it into your calculator. Find out. Round each decimal number to the nearest thousandth. Okay, so the thousandth would be a third decimal place. Okay, but this only has one decimal place. No, it doesn't. Remember, it's got an infinite number of decimal places. This is actually 0.33333333. Okay, so if we just take this number out and say it, it equals this, it's not the simplest way to write it, but it's the same thing. It's 0.333 with the 3 repeating. We want to round it tenths, hundredths, thousandths, this 3. So that's based on this fourth number. So since this fourth number is less than 5, we round it to 0.3333. or 0.333. Remember, this is not exact. That's why I use these little squiggly equal sign. That's approximately. Okay, let's do this next one. 0.6 repeating is 0.6666. I'm always going to take it out to 4 decimal places so that I can round it to 3 decimal places. Okay, so now that this fourth digit is greater than 5, that means I have to round the third digit up to a 7. Next one, the 3 and the 6 are repeating. 3, 6, 3, 6. I need to take it out 4 decimal places so that I can round the third one. This 4 is going to go up to, I'm sorry, this 3 is going to go up to a 4 because the 6 is greater than 5. Again, last one, we got 1.8 and then 6, 6, 6. Only the 6 repeats. Okay, and since this 6 is greater than a 5, this 6 is going to get rounded up to a 7. Okay, we don't, only round when you're asked to do so. Go out as many digits as you need to. If we were asked to round to the nearest 10,000th, the 4th digit, then we'd have to go out to a 5th digit to be able to know what to round to. These should really be the old squiggly equal signs right here, shouldn't they?